Jay, what happened?
Popped my tire.
You popped the tire?
I put out spikes or something.
All right.
What the hell happened?
The tire.
No, I didn't. What are you talking about? Yes, you did. Dude, I don't see
The
it.
tire's flat, man.
I lost anyways.
Tire loss.
Yeah, I might have been you. Maybe. Yeah, now that I'll probably still be with a flat tire.
All right, we gotta pump the tire back up.
Yeah, we can do that over there.
All right, let's go.
I'll still be McCormick. You caused it! No way! Fix it. How much air did I get? Alright.
Oh man, let's measure this tire so we can figure out how much air we need.
Alright, that sounds good.
All right, let's see. From here to here is about 5.5 inches. Let's see. From here to here to here is 10 inches. And the width out is about 1.5 inches. All right, let's go integrate it and figure out how much. Let's go integrate it and figure out how much we need to fill up this tire.
This is a graph of our approximation on the inside of the tire.
To find the volume of the ATV tire, we integrated two functions that represented the outer edge of the tire and the inner edge of the tire, and rotated it around an axis using the rotation formula with bounds from 0 to 10. As you can see, Patrick is typing the functions into the calculator and the integral so that we can find the volume of the tire. Okay, from our calculations, we found out that the volume of the tire equals approximately 2,681 cubic inches. From science, we learned that ideal gases have a common relationship between pressure, volume, moles, and temperature. So we found that we want 7 psi as a pressure. The volume is what we found, which was 6,281 inches cubed. The R is a constant that it relates to mole, and the temperature was 81 degrees Celsius. But we need to convert all of these units into useful units for the constant to cancel out the relationships. Now that all our units are converted into useful units, we can now plug them into an equation so that we can find the number of moles of air that we have in the tire at 7 psi and find the volume needed from that. From our calculations, we find that 1.988 moles of air are found in the tire at 7 psi. Okay, now that we have found how many moles of air there is in the tire at 7 psi, we need to figure out how much volume that it takes to get 1.988 moles of air. At 25 degrees Celsius, which is approximately 27.62 degrees Celsius, which is equal to 81 degrees Fahrenheit, which was the temperature that our tire is at outside, it is 24.46 liters per mole of air. So with our 1.88 moles of gas, there's 24.46 liters per mole of gas is equal to approximately 48 liters of air needed to make a tire of that volume 7 psi.
Gotta air up this tire right here now. If you put a hole in it for me. You wanted it. Trust me. You don't want to lose too bad to me. 7 psi. Keep going.
Squiggle, 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 squiggle. Oh, crossover. Uh-oh. Squiggle, 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 squiggle. Squiggle, 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 up, brownie berries. Squiggle, 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 oh, squiggle, squiggle, oh, squiggle, 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 oh, dead end, dead end. Circles and triangles, circles and triangles. Oh, Curry, you like this one. Up, chucking back, up. Help me! I'm bleeding. It's McCormick. No, yeah, it's McCormick.